Today we are solving the sine of theta equals 0.23, and our domain is much bigger than the domains we've used in the past. We are specifically finding solutions in the domain negative 360 degrees to positive 360 degrees. And before we get started, I think it's going to be helpful for us to draw a graph. So our graph is going to look something like this, with our maximum value being 1 and our minimum value being -1. This point clear over here is negative 360 degrees. It touches 0 at negative 180 degrees there. We have 180 degrees here, and then 360 degrees here. So those are the big ideas on this graph. I do want to point out that there are two complete cycles in this wave. So here's one complete sine wave, and here's the other. Okay, so we'll talk about why that's important in just a second. So let's go ahead and get started solving this, and then I'll show you why we are going to have exactly 4 solutions. So my first step is to take the inverse sine of both sides. I'm going to write that out so you all can see exactly what I'm doing. So when I take the inverse sine of theta, I'm left with theta. When I take the inverse sine of 0.23, what I'm doing is I'm putting that into my calculator, and my calculator is giving me the value of 13.3 degrees. And that is one of our solutions. It falls within our domain of negative 360 to positive 360 degrees. Okay. And if I am just thinking about my graph, I know that I'm looking everywhere that sine of theta has a value of 0.23. So really what that means is I'm looking at where the graph of sine of theta intersects with the graph of y equals 0.23. And when we do that, I know it's probably like right about here. So that means I'm going to get 4 solutions out, right? And 13.3 degrees is this solution right here. All right, so now we are going to apply a property because we know that both solutions have to fall within 180 degrees to find our second value. And when I do that, my property that I'm applying says I take the value I just found away from 180 degrees. So 180 less 13.3 degrees gives me my second value of 166.7 degrees. Okay, that also falls within our domain, and that is this value here. So just a reminder, you're going to notice that the 13.3 degrees and the 166.7 degrees are equidistant from 2 points. So 13.3 degrees is exactly 13.3 degrees from 0, and 166.7 degrees is exactly 13.3 degrees from 180. So they're symmetrical on our sine wave. Now, we found both of those values. Since these sine waves repeat every 360 degrees, that means that exactly 360 degrees from this point, I have my next value. That's going to be this point. So the way I find that value, I'll come here, is I say I take my value that I had, 13.3 degrees, and I deduct 360 degrees from that. And when I do that, I get my first value of negative 346.7 degrees. So that's this one right here. And by that same logic, I am going to take this value and deduct 360 degrees, and I will find that value. That color really doesn't show up, so I will use yellow. So I'm finding this value by deducting 360. So I'm going to say that theta equals 166.7 degrees less 360 degrees. And when I do that, I find a value of negative 193.3 degrees. That value falls within our domain, and it's right here. It's exactly 13.3 degrees away from negative 180 degrees. And this value right here is exactly 13.3 degrees away from negative 360 degrees. These are our 4 solutions. Thank you for joining me. Make sure to subscribe for more math videos. Till next time, remember, you've got this.